Hi, good morning. So today we're going to continue with the water in and out problem. Let's take a look at number 1. Water is pumped into a tank at a rate of Wt equal to 3 square T gallons per minute. And water leaks out of the tank at the rate of R of T equal to 9 gallons per minute. For T's between 0 and 16 inclusive, at T equals 0, the tank contains 800 gallons of water. So the questions are giving us the rate in, that is Wt equal to 3 square T gallons per minute. And then we had the rate out, that is R of T equal to 9 gallons per minute. And then at T equal to 0, we get 800 gallons of water. So we learned it yesterday. To find the amount of water in the tank, so we can let the P of X or P of T equal to the amount of water in the tank. Then P of X equal to integral 0 to X rate in dt minus 0 to X the rate out dt and plus the initial amount. So now in this case, we got P of X equal to integral 0 to X Wt dt minus integral 0 to X R of T dt, and the initial amount is 800. So this is the information that's given. So now let's take a look at part A. Is the amount of water in the tank increasing or decreasing at T equals 4? Just to find your answer. The keyword is going to be amount of water increasing or decreasing. So part A, so basically the question asks you, is P of X or P of T increasing or decreasing at T equal to 4? So if we want to find a function whether it's increasing or decreasing at a time T equals 4, that means we need to use the first derivative, P prime. So if P prime of 4 is positive, then P of X is increasing at T equal to 4. So if P prime of 4 is negative, then P of X is decreasing at T equal to 4. So in other words, if the slope is positive, then the function is increasing. If the slope is negative, then the function is decreasing. So right now, let's take a look at this function that we have again. So we got P of X equal to integral 0 to X Wt dt minus 0 integral 0 to X R T dt plus 800. So if you want to find P prime, so we're going to find the derivative of the integral. So we substitute the X into the T. Whenever we see T, we place X. So we get W of X times the derivative of X, which is 1, and minus, so we do W is 0 minus 0 because the derivative of the 0 is 0. So we do the same thing over here. So we got the R of T, so we replace the T by X, and the derivative of X is 1. And then we substitute the lower limit into the T, so we got R of 0 times the derivative of 0, which is 0. And now we find the derivative of 800, which is 0. So we simplify it. So we got w of x minus 0, and then minus the r of x, and then put 0. So basically, p prime equal to wx minus rx. So let's take a look at this. W is the rate in, and r is the rate out. So in other words, so p prime equal to the rate in minus the rate out. So now we got a new way to find the p prime without doing this. Of course, if you want to, you can repeat this every single time. If you remember the relations, and now we can start from here. So in part A, so we said let p of x equal to amount of water in tank. Then p prime equal to the rate in minus the rate out. So we get w of t minus r of t. And then we let p prime of 4, because it's at t equal to 4, equal to w of 4 minus r of 4. So we had to find out it's going to be positive or negative. So we had wt equal to 3 square root t, and r of t equal 9. So w of 4 equal to 3 square root of 4. 3 times 2, you get 6. And then r of 4, this is constant, is there a constant? So p prime of 4 equal to 6 minus 9. And then p prime of 4 equal to negative 3. This is negative. So the slope is negative at t equal to 4. So we can say that because, p prime of 4 is negative 3, which is negative, then the amount of water is decreasing at t equal to 4. So this is going to be the one of the method. So some people say, can I do another way? Definitely. So we're going to use the second approach for part A. So now part A, method number 2. So we got the rate in, which is Wt equal to 3 square root t gallons per minute. In the rate out is going to be R of t equal to 9 gallons per minute. So at t equal to 4, W of 4 equal to 3 times square root of 4, which is 3 times 2 is 6 gallons per minute. At t equal to 4, R of 4 equal to 9 gallons per minute. Then we compare the rate in and rate out. So the water going in at a rate of 6 gallons per minute, and the water going out is bigger, which is 9 gallons per minute. So that means you're going to have decreasing in the volume of the water. The rate goes in is less than the rate goes out. Then the amount of water in the tank is decreasing. Okay, so we finished part A. So let's take a look at part B. So is the amount of water in the tank increasing or decreasing at t equals 16? So now we say increasing or decreasing. P, we're going to use P prime. So P prime equal to the rate in minus the rate out. We already proved it in the very beginning. Then P prime equal to WT minus R of T. So P prime of 16, because we're going to talk about 16, equal W of 16 minus R of 16. So WT equal to 3 square root T, W of 16 equal to 3 times square root 16. So 3 times 4 equal 12. And the R of T equal to 9. So R 16 is still equal to 9. It's a constant. So we got 12 minus 9 equal to 3. Positive. So if the slope is positive, then P is going to be increased. So because P prime is 16 equals to 3, it is positive. So the amount of water in the tank is increasing at t equal to 16. Now let's take a look at method 2. You don't have to do both methods, you can just choose one. So the rate in at t equal to 16, so you get W is 16 equal to 3 square root 16 equal 3 times 4 equal 12 gallons per minute. And then the rate out at t equal to 16, R 16 equal 9 gallons per minute. The water goes in at 12 gallons per minute. The water goes out at 9 gallons per minute. So definitely, then you will see the volume of the water will be increasing. So the rate of water goes in to the tank is bigger than the rate the water goes out of the tank at t equals 16. So the amount of water is increasing at t equal to 16. So there are two different ways to show the work. So you choose the way that you feel comfortable. Now let's go to part C. Part C. At what time t, for t between 0 and 16 inclusive, is the amount of water in the tank an absolute max? So P of x equal to amount of water in the tank. So P of x is going to be absolute max. So we have to use P prime. So now we're going to use a Fourier duty. I'm going to find the critical value, and then we're going to use side chart and determine where they're going to have the lattice max, lattice mean, and then if there are more than one value, we're going to compare, and then eventually we're going to find the biggest value that will be the absolute max. So now we're going to write P prime equal to the rate in minus the rate out, so which we got WT minus RT. So we did that before. So V prime equal to the rate in minus the rate out. Okay. So now we are going to make P prime equal to 0. Let the first derivative equal to 0. So we got WT minus RT equal to 0. So we had WT equal to 3 square root T, and RT was 9. So we plus 9 both sides. So we got 3 square root T equal to 9. Divide by 3. So we get square root of T equal to 3. And then you square both sides. So we get T equal 9. So this will be the critical value. Now we're going to draw a side chart. If you had to compare absolute max, absolute mean, you had to do the side chart because it's a closed interval. 0 to 16, and you get 9. So we're going to put P prime. So P prime is going to be 3 square root T minus 9. Now we're going to use the 0 because it's inclusive, and use 16 also. So now we got 3 square root 0 minus 9, definitely going to be negative. And then 3 square root 16 minus 9. So 3 times 4 minus 9 is positive. So now we're going to have to go down to the P 9 and go back up to P 16. So now we get 2 relative max. And you get a relative mean, and it's also the absolute mean. But the question never asks for the absolute mean, so we're going to skip that. We just concentrate on the absolute max. So we already know that P is 0 equal to 800. Now we just have to find the P of 16. So we get to 0 to 16 WT dt minus 0 to 16 RT dt and plus 800. So now we get 0 to 16 WT was 3 square root T dt. And then 0 to 16 RT is 9 dt and plus 800. So now we're going to rewrite this. So you're going to 0 to 16, 3 times T to the half dt, and this one will be 19. And we got 0 to 16, and then plus 800. So I'm going to do this part. So you're going to get over here, you will get 3 times T to the 3 over 2 over 3 over 2, 0 to 16. So 3 times, you will have a fraction, you flip it over, and then you get T to the 3 over 2, 0 to 16. They simplify, so we get 2. There will be square root T to the third power 0 to 16. So we got 2 square root 16 to the third power minus 2 times 0, which is 0. So 2 times the 4 to the third power. 2 times 4 to the third power is 64. So we got 128. So now we go back over here. You get 128 minus, 9 times 16 minus 0 and plus 800. So 128 minus 16 times 9. So we got 54, 144 and plus 800. So we are going to add it together. We got 928 minus 144. And then we subtract. So we got a 4, 8, 7. So 784 gallons. So we got P0 800, and then we got P16 equal to 784 gallons. So definitely 800 is bigger. So therefore this one will be absolute max. So conclusion, the amount of water is an absolute max at T equal to 0. So we finished question number 1.